All right, activity 2.3, more with probability models. When Mr. York receives his homeroom list for this year, he cannot believe it. All of the last names in his homeroom start with one of 5 letters. The table shows how many students in Mr. York's homeroom have last names beginning with the letters listed. How many students are in Mr. York's homeroom? So I have to take those and I have to add those together. So 7 plus 4, 11, plus 5, 16, plus 12, 26, 28, plus 2 is 30. So 30 students. Create a probability model for selecting a student from Mr. York's homeroom. All right. So probability model is going to have my outcome, and then it's going to have my probability. And hopefully you're trying to do this first and then you're trying to check your work versus what I do. And then you could be yelling at me if I make a horrible mistake, which would be amusing. So the last name could start with an A, and there are 7 of those out of 30. Or B, and there are 4 of those out of 30, which I could say is equal to 2/15. Last names that start with an M, like Molnar, is 5 out of 30, which I could reduce down to 1/6. S is 12 over 30, which I can change into 2/5. And then O is 2 out of 30, which I could reduce to 1/15. Okay. So that is my probability model. I notice that they are different, so it's a non-uniform probability model. Hopefully I don't make that mistake again. Then use the probability model to determine each probability. First, randomly choosing a student with a last name that begins with a vowel. Well, if I look at this, I could have A, which is 7/30, or I could have O, which is 2/30, which would give me a 9/30 probability. Randomly choosing a student with a last name that begins with a vowel. 7 out of 30. O is 2 out of 30. 9 out of 30, which could be the same as 3/10. Okay. And then that could be 3/10, or that could be 30%. Okay. B, randomly choosing a student with a last name that does not begin with S. All right. So I know the whole probably all the kids is 30 out of 30. Then those with an S is 12 out of 30. So I'm going to take that away. And then I would be left with 18 out of 30, which I can simplify down to 3/5, which is the same as 6/10 or 60%. Last but not least, randomly choosing a student with a last name that begins with a C. And there are no students that have a last name that begins with a C, so there is a 0 probability of that. It is impossible in this particular situation. Okay. Quickly, a look at the talk. Compare and contrast. Your best friend is not in school today and misses this lesson. Oh, none of us are in school. Help your friend understand what you have learned. Write 1 to 2 paragraphs, no, that explain the answers to these 2 questions. Just think about the answers for a little bit. What is the difference between a uniform probability model and a non-uniform probability model? Uniform, the probabilities are the same or uniform for each outcome. For a non-uniform, the probabilities are different between the outcomes. All right. 2. Will the sum of all the probabilities of the outcomes of an event be equal to 1 for both uniform and non-uniform probability models? Yes. The sum of all outcomes for an event will always be 1. Yay! Ladies and gentlemen, that was the end of lesson 2.3.